Welcome everyone to my presentation. Today I will talk on conceptual study of a net zero energy poultry house for Mediterranean climate in the USA. So this study was conducted by the undergraduate student in my research group, and I'm presenting on behalf of them. Our world population is increasing and we have to produce more food to ensure the food security for this increased population. And the study is showing that the egg consumption will increase by 2.4 kg per person by 2030. And this increased food production also consumes a significant amount of energy, which is about 10% of the total energy used. And if you'd like to produce more food, we are consuming more energy. And this graph is kind of showing the different component of the expense for the livestock production in the USA, and it's showing that the poultry consumes significant amount of energy, which is a kind of about 2% of the total expense for the poultry production. The problem is that the poultry houses are mostly powered by non-renewable sources, which is costly, and also at the same time it pollutes the environment through emission of carbon dioxide gas as well as other greenhouse gas emission. The solution is that if we can achieve the net zero energy status for the poultry house, we can minimize the impact, and finally we can achieve the net zero energy status and ultimate target of the carbon neutrality for the poultry house. I would like to give some basic high-level idea about the net zero energy concept. So it means like if the facility could produce more or equal amount of energy from renewable sources than the energy consumed on an annual basis. This energy status or the net zero energy status could be achieved through improving the energy efficiency of the building envelope, and also use the efficient control system, and also use the renewable energy based system for operation of the facilities. This could be within the footprint, and also could be from outside of the footprint, and some additional energy produced from the boundary could be transferred to the grid. So the research goal is to study the potential of the net zero energy status for the poultry house. And the specific objectives of this study was to develop a quasi-steady-state energy balance model to simulate the heating and the cooling demand based on hourly based simulation, and also study the potential of the net zero energy status for the poultry house in California, and finally conduct a sensitivity analysis to minimize the energy consumption for the poultry house. So this model was developed based on the energy balance equation, considering the different heat sources and sink, like the chicken, the solar radiation heat transfer through wall, floor, and the roof, as well as through the ventilation. This model was developed with some major assumptions like negligible heat from the machinery and the lighting, the uniform indoor temperature, and also the negligible impact of water evaporation. And based on that model, it can simulate the hourly based heating and the cooling. When the cooling is required, this model can also calculate the ventilation required for the direct evaporating cooling system to achieve the required the cooling load. So I'm not explaining the other component of this model, but I would like to give some idea about the model that was considered to calculate the energy production from the PVT system. So in that case, we just use the commonly used equation to calculate the solar radiation available on the tilted surface. Then we use the EPA model to calculate the amount of power that could be generated from the PVT system. In our model, we also considered the different non-HVAC related energy used, like the egg belt and packaging, lighting, manure belt, and the feeding system. For doing this calculation, we considered the data from the reference, and that was considered constant over the day. Finally, we write a computer program for hourly simulation based on the input of the structural data, weather data, and the indoor set point parameters. the model can simulate the heating, cooling, as well as the other energy used for non-HVAC purpose. So after developing the model, first we tried to validate the model using the secondary data from one of the studies that was conducted in Indiana. So these houses indoor set point temperature was considered 23 to 27 degrees Celsius depending on the season, and the chicken number was 50,000, and the minimum ventilation was considered 0.56 cubic meter per hour per bird. So based on the comparison with the measure data, we can see the model can predict closely with the measure data, except for the month of November and December. This could be even simply because of opening the door during this cold period that was not considered in the measurement. So excluding the November and December data, we can see the average error is 8.5%, which is quite acceptable. Then we focused on the case study for a conceptually designed poultry houses for Davis, and based on that, we conducted the further analysis to achieve the net zero energy status for the design house. So in that case, we considered the dustman caging system with the floor area of 1880, and the set point temperature was considered 22 degrees Celsius from November to March, and 28 degrees Celsius from April to September. And the number of the chicken was 69,376. And the sensible heat production from the chicken was 4.1 watt per kg during lighting time, and 3.2 for the dark period. And the minimum ventilation was considered 0.6 to maintain the indoor air quality. And the evaporating cooling efficiency was considered 90%. So this is showing the schematic of the building that was designed conceptually with evaporating cooling system with tunnel type ventilation. And this is showing the design PVD system on the roof of the house. So then this graph is kind of showing the weather data like the temperature and the relative humidity in Davis. So you can see the August is the hottest month, and the relative humidity could be significantly dropped during the summertime. Then we try to analyze the different heat sources and sink in the house. So we can see that the ventilation is the major component for heat transfer from the house, and from the roof is the second component in terms of the intensity of heat transfer. So in terms of the energy production, the chicken is the major component to produce the heat inside the control volume, and very small amount of energy could be also gained from the solar radiation because of solar radiation transfer through the windows. Then we try to analyze the heating and cooling loads. So based on the analysis, we found that the heating cost in the poultry house is negligible based on the indoor set point temperature, number of the parts, and the building insulation we considered in our analysis. The cooling load varies with the temperature, and you can see that the maximum cooling required in the summertime, but this could be even very higher compared to the graph that is showing on the graph, because in our simulation we use the indoor set point temperature to the highest level to reduce the energy use. So that's why these even not showing that much significant. Finally, we also try to analyze the energy use for the different component, and we can see the egg collection and package required the maximum energy use, and the ventilation required 25%, which is the second largest energy use in the house. Finally, we try to kind of compare the energy production versus energy consumed over the year, and we can see there have some surplus energy production from March to up to the August, and the negative value could be minimized from the surplus energy production from the summertime. And in terms of the annual basis analysis, we can see the 4.8% is the surplus for considering 50% of the roof area covered with the PVT system. And finally, we conducted some sensitivity analysis for the insulation value for the roof. And we can see if we increase the insulation, the heating could be become negligible and the cooling could be increased. In terms of the total energy consumption, we can see they have some optimal point. So the 5 hour per feet square BTU value could be the optimal insulation value to achieve the minimum energy consumption in the house. And based on that study, we can conclude the heating cost could be negligible in DVs, and the energy production from the PVT system could be sufficient to achieve the net zero energy status for the poultry house in California. And in future, this study could be further extended through validation against the hourly measure datum, and also the optimize other design parameter to reduce the energy consumption, and do some economical feasibility analysis and also the life cycle analysis for understanding the environmental and the economical benefit of the net zero energy poultry house as compared to the current practice. And thanks for your participation. I would be happy to answer your question through email as well as during the question and answer session at the conference. Thank you.